Now you can see, it says there, a function capital F of x is defined as, and then they give you two things, right? They give you two different functions. You might want to get a red pen out, and we call these sub-functions. They're parts of a function that make up another one. So it's a bit like what we did with the circles and breaking up into pieces. Okay? Now I'm going to write this a little bit differently than what's on the page, because this is how you'll actually get it. You've got one function and it's defined into, or really as many as you like, pieces, hence piecewise. Okay? So here we've got, it's equal to this for a particular set of values, namely those ones. Okay? And for other values, it's equal to a different function entirely. Okay? Now, the question doesn't ask it, but we're going to do it. What does this thing look like? Because it's quite a simple example, it's not that hard to picture. So draw your set of axes as usual. And generally we go from left to right. That tends to be the easiest way for our brains to handle it. So the leftmost part is this one, x is less than 0. Okay? So a nice idea is to start from your boundary. Okay? In this case, 0. Now, there's the origin. I'm going to put it up here. Okay? And you all know what y equals x looks like. Okay? So I'm just going to put my line off down here. And I'm going to label that part. Now, the rest of the function is defined for this. Okay, you'll notice as well, I didn't put anything on the origin there because I wasn't sure. This thing doesn't tell you what's happening at the origin, right? It means to the left of the origin, everything else. This is where the origin is defined, so it's 2x. So it's the same line but steeper. Okay. So, put that in. Okay. So, that's what the graph looks like. Pretty simple. It's a nice gentle start. I hope, by the way, this seems familiar, this whole labeling of different, you might have called them branches before. You dealt with this at the end of last year, right? When you were doing, where did you, yeah, absolute value. You got heaps of functions that look like this, and then I bent off and did weird things, okay? So absolute value, you know, like this, is really, it's really a piecewise function. We just didn't give you the name, okay? So that's really equal to, how would you describe it? Actually, this is the definition of an absolute value, right? It's equal to x on what condition? It's similar to this, isn't it? For x is greater than or equal to 0. Okay. What's it equal to for the rest of the domain?
Negative x.
Yeah, thank you. It's flipped upside down. Now, some of you might be curious, how come I've got the equality here and not here? And the reason is, well, no reason. In this case, I could flip it over and it'd be exactly the same. Right? No change, really. Okay? But I'm going to show you some example in a second where it does make a difference. Okay? Now, question. Why are we learning about piecewise functions? Is it just because mathematicians want to make life hard for you and they want to make one graph twice as hard to draw? What do you think? Why are we learning this? Because you can, you're smart enough. Let me suggest, piecewise functions, your life is full of piecewise functions. You just don't really think about it, okay? Example, during the holidays, I assume you went to the shops a fair bit, right? Shopping centers, that kind of thing. And I'll probably, does anyone have their license here, like their Ps or anything like that? You're all nerds, you're present when you drive. Okay, when you get to drive, you have to worry about parking, right? Parking. Now maybe you already thought about parking before. How does parking work? When you pay for parking, how does that work? Well, when you drive up to Parawesha, right, there's a sign right there telling you what you're about to be forced to pay. Okay? They say the first 3 hours are free, right? So 0, 1, 2, 3. If I say time, how long you've been in the car park, right? All of that, it costs you nothing. Okay? Zip, yeah? But then the second you go over, I actually don't know what the numbers are, but it's something like, I don't know, $2 or $2.40 or something like that. So as soon as you hit 3 hours, you're something else, right? 3 to 4, or 3 to 3.5, or whatever it is, okay? and then when you jump up to the next thing, and then when you jump up to the next thing because they're extortionists, that kind of thing. Okay? What's this? That's a piecewise function. Okay? Let me give you one more example before I leave off this. Who's got a job? Does anyone have a job here? Can't drive, can't. Oh, you got it. What do you do?
I tutor a kid.
Oh, wow. Wow. Okay. It's interesting. You probably get cash in hand, so this probably doesn't apply to you. But, do you have...
I umpire.
Oh, yeah? Okay, all right. So whenever you get paid... Ooh. Oops. Just push it back. Do you want to...
That wasn't me.
Yeah, just wear it.
I didn't do it.
Yeah, let's edit that out, okay. Is it still recording?
Yeah.
He's like, I don't care, whatever. I'm just going to leave that in, that'll be great, okay. You watch it back in, oh, I remember, that's when. Anyway. Okay, now, when you earn money, assuming someone doesn't just very shadily put, cash in your hand, if you have to get a salary or something like that, okay, the government takes money off you, right? And we call that tax. So tax is something you got to pay back, right? Versus your earnings. Now maybe because you're sick of consumer arithmetic from year 9, you know basically how this works, right? There's a similar kind of system. It's not 3 hours. It's like your first, it got changed recently. It used to be $5 grand. I think it's increased a lot. Yeah, it's some number of thousands of dollars, right? So this is how much you earn. Okay? And you pay no tax, right? But as you start to earn more, you start paying tax. Your first dollar over $18,000, you pay some number of cents, right? So it's not quite like this. It's not like, oh man, I earned $18,001, so they take this big cut out of me and it doesn't change. That'll increase for every dollar you earn, right? But that's not all it does. It doesn't do that forever. You meet what's called a tax bracket, right? So you earn more. I can't remember what the numbers actually are, but yeah. Well, okay. So my scale looks terrible for that. So I'm going to call that like 21 or something like that. Okay. So what they do is, you've seen the table, right? They take more cents out of the dollar. Okay. So what effect does that have on this? It climbs more rapidly. Okay, and then it climbs really rapidly, right? Or it doesn't quite do that, but you get the idea. Okay? What happened to myself? Okay, so that's a relation. Bad idea. You get the idea. Okay. So again, piecewise function. Okay, piecewise functions exist everywhere in life where things don't fit normal rules for everything. Okay, we want different rules for different things, or different rules for different people, or anything like that. Okay. So, that's piecewise functions. I'm about to give you a whole bunch of examples. They're not on this sheet because I couldn't find a good exercise for it. And what I want you to do is draw yourself a new set of activities for each one, and then graph them as they appear. Now, I'm going to give you more than 2 subfunctions per function because that's what you'll get in exams. And I'm also going to give you a few where they don't behave nicely and don't meet at one point. They're going to do this. Okay. So, if you've got another color there, you might want to label this. A graph like this, as opposed to those two, right? It's full of discontinuities. It is not, it is not continuous, right? And that category will become really important later when we do calculus and limits, okay? So, watch out for that. Quick question. You can see my filled and hollow circles, right? How will you know 3 hours, for instance? How will you know this one should be filled and that one should be hollow, or the other way around? How can you tell? Yeah.
I'm joking.
That's right. So look carefully. This is what we were talking about before. Look carefully at where there's an equality there, right? Where there's an equality, that's where I'm going to fill the circle. Okay. So I put the circle up here because I know they say under 3 hours free. The second you hit 3 hours, if you were driving out and it equaled 3 hours, they'll charge you. Okay, so that's why it's a filled circle